Welcome to the Solid Edge Tips and Tricks video, working with adjustable parts in assemblies. Displaying deformable parts like a suspension, bellows, and springs in a mechanism like a clamp is a common requirement in assembly modeling. With other CAD systems, users are compelled to create multiple parts with the required lengths of the variations, store them separately, and use discrete parts as per the need of the target assembly. Solid Edge with synchronous technology gives you an unprecedented advantage by allowing you to design a part with a specified variable as driving, which makes the part adjustable. Let's take a look. Here is the model of a spring, which was marked as adjustable when it was created, with its height specified as a dimension to vary and adjust when the connected components move in its assembly. As you can see, when the spring is inserted in the assembly, you can specify it to be used as adjustable and match a corresponding assembly variable that it should update with. Solid Edge then asks which assembly variable I want to make equal to the length variable of the adjustable spring. But you can also choose to measure the distance between two faces in the assembly and set that dimension as the variable. Then insert the spring, which is an adjustable part, between the two faces. To proceed with assembling the spring, apply the regular assembly relationships between connecting faces. This places the spring in position, but its adjustable potential remains untapped. You can also use this spring multiple times in the same assembly without making discrete copies. A new virtual spring is created in the assembly, and the original part remains unmodified. Finally, start making design changes to the assembly according to the functional requirements. Rotate or move components which are connected to the adjustable spring. As you can see, Solid Edge takes care of the rest and ensures the spring height always displays with the exact length as desired. Advantages of making a part adjustable are multifold. First, they save the hassle of maintaining multiple parts. In addition, there is no need to know in advance how many discrete variations the adjustable variable needs to make, since the varying dimension is adjusted dynamically to virtually any value according to its function in the assembly, saving you time and increasing productivity.